recording. Here we go. Exercise 1B, multiplication division of numbers. The two skills you're going to be learning. Short division and long multiplication. Those are the two key skills in the fluency section. Those who then are good at that will then move on to problem solving and then reasoning and enrichment. Okay, but I at least expect everyone to at least learn fluency because that's the bare minimum at year 8. Okay, let's fill in some points. In this exercise, there are a couple of terms that you may not know or you may have already learned but you didn't know it. Commutative law. This means, fill it in, this means that order doesn't matter. So write that in. Order doesn't matter. Now, in mathematics, especially at the junior level, you got your 4 key operations. You got addition, that's an operation, subtraction, multiplication, division. Now, which one of those 4 popular ones where its commutative law does apply, meaning the order does not matter? Kyle. Addition and multiplication. If you think about it, see, addition, if you wrote 2 plus 3, that's the same thing as writing 3 plus 2. It doesn't matter if you swap the order. Same thing with multiplication. If you wrote 2 times 3, which is 6, and you wrote it the other way around, 3 times 2, it's still the same. Whereas subtraction, it does matter if you said 3 take away 1 versus 1 take away 3. They're two different ones. One is 3 is bigger than 1, so you're taking 1 from the 3. Here, 1 is smaller than 3, and you're trying to take 3 from something that's smaller. That ventures into negative numbers. Okay, and that's what we're doing this term. Right? So there are two different ones there. There's two different answers there. Same thing with division. Division, a lot of students, when they see 1 divide 2 in their heads, they're thinking 2 divide 1. They tell me the answer is 2. It's not true. If you only got $1 and you're dividing it by 2 means you're sharing to 2 people. If you have $1, how much does each person get? 50 cents. Yeah? It doesn't make sense if you get $2 each. If that person gets $2, the other person gets $2, it should be $4 in total. But if you got only $1 in total, that means that each person has to get 50 cents. It's half. So there's a difference between 2 divide 1 versus 1 divide 2. So the order, when we say order doesn't matter, that's commutative law. And here is an example over here for you to write down. 2 times 3 times 4, you can write it as 4 times 2 times 3, and the answer is still the same. Or you could also write it as 3 times 4 times 2. Okay? That's what commutative means. Next one. Associative law. Associative law means that grouping, and right here, doesn't matter. Now we've learnt BODMAS. There's orders of which comes first. So times, division comes first, but brackets comes even earlier than that. So BODMAS. There are, again, 2 operations out of the 4 operations where grouping does not matter. Which 2 operations do you think where grouping does not matter? Yes, wait, let me learn. Liam? Yes, that's correct. Addition, multiplication again. And here's the example. You can group, so putting brackets in means you have to do 2 times 3 first, then you times the 4. Okay, so this is the order. 2 times 3 is 6, and then 6 times 4 gives you 24. But even if I grouped it differently, if I group 3 times the 4 first, so brackets, the order says you have to times this first before you times the 2. If I group this one first, that still gives you the same answer. 12 times 2 is still 24. This is what grouping is. So you find that addition is the same thing. If I wrote 3 plus 2 plus 4, it doesn't matter how you group them. You can group 3 and 2. The answer is still going to end up being the same. This is called associative. These laws are more important when you get to algebra. When you get to algebra, it matters. A lot of students don't realize this. I'll give you an example of an algebra one. A times B. See, I don't know what A times B is, but what I definitely know is that if I see B times A, it should be the same. Because again, commutative law says order doesn't matter for multiplication. Even though I don't know what the number is for A, I don't know what the number is for B, but I know even if I swap the order, it should still be the same. So you do that when you get to algebra, collecting like terms and sets. Okay? Last one. Distributive law. You'll find this is useful for mental strategies. When you're doing the questions that ask for mental strategies, 9 times 73, some of you might be doing this in your head. You might be writing 73 times 9, and then you follow the algorithm and you say 9 times 3. What's 9 times 3? Can I please have, let's go with Leon. 27, put the 7, carry the 2, and then 9 times 7, what is that? Can I please have, let's go with Wilbur. 63, adding on 2 gives you 65. So you get 657 through this algorithm. You can do that in your mind. Okay? Or distributive law says, well, sometimes the numbers are too big. I know my times table is from 1 to 12, but 73 I don't know. So what they do is they say, well, why don't I write it as 9 times? And instead of writing 73, we can write 73 as 70 plus 3. You see that? So I'm splitting up the 73 into 70 in 3 units. The distributive law says, well, since you're doing 9 groups of 73, it's the same thing as saying 9 groups of 70. So you're saying 9 times 70. So 9 groups of 70s. You've got 9 of these 70s. And you also have 9 of these 3s. Because when you say 9 times 73, that's what you're actually doing. You're doing 9 groups of 3s and 9 groups of 70s. That's what you're actually doing there. So here, if you split it out, 9 groups of 70 and 9 groups of 3, this is easier to do in your head. You see, we do know 9 times 3. 9 times 3 is 27. What's 9 times 70? Elizabeth? 630. Because we know 9 times 7 is 63. Add on the 0. Why do we add on the 0? Because you're times it by multiples of 10. Okay? So we know this is 630, and it's easy to do it in our head. 630 with an extra 27. What does that give us? 657. Exactly the same. Okay, so this is called distributive law, that you can actually split it up. You can break it up. As long as it all adds up to 73, you can actually times it up individually. In fact, some of the secret rules that you find on TikTok and Instagram, my mates tend to send me that, and they're like, hey, did you see this little trick here? And I look at the trick and I'm like, it's not a trick. It's actually just this law. It's just distributive law. So when I teach them and how to simplify and factorize, they're like, oh, school never taught me that. We always have. We taught you all the skills, but all those little tricks is based on this algorithm. Okay? All right, so that's your basic theory. Let's do the algorithms that you need to know for fluency, okay? Here we go. Let's break it apart. 5 times 160 is what you can write down. You can break it up into 5 times. And you can do it as 100 plus the 60, or you can do 16 times 10 is up to you how you want to break it up. But I would break it up into 100 plus 60. That's much easier. Distributive law. Which 2 do I multiply again? Let's go with, who haven't I chosen? Sully. What am I going to multiply now? Using distributive law.
5 times.
Yep, 5 groups of 100, which means I write here 5 times 100. Plus, what else am I going to multiply? Let's go with Bo. I'll move up here so you can see the pattern. What's similar about these 2? It's okay not to know. That's correct. So that's what I'm trying to say. See how that's 73? 73 is too hard. We break it up. 70 and the 3. 160 is too hard. So we break it up into 160. Yeah? So 5 groups of 60 means that you're going to times 5 times 60. This is much easier to do. 5 times 100. What's 5 times 100? Let's go with... Let me try to remember names here. Who have I got? Edison. What's 5 times 100? 500. Very good. So we got 500. Plus, what's 5 times 60? Let's go with man. 300. Very good. 5 times 6 is 30. Add on the extra 0. Multiple of 10. That gives you 300. Now that's much easier to do. 500 plus 300. What's 500 plus 300? Can I please have Elliot? 800. Very good. This is one mental strategy. You can come up with any other method. That's just the other one I'm showing you. Division. One of the shortest ways is short division. You can use long division, but I think short division is easier. So here, what I find students tend to confuse, see that divide 4? That will always, whatever you're dividing by, always goes outside the operation. So when we write it out, this is your symbol, the division. The 4 goes on the outside. And then the 232 goes in the inside. Okay? This is why students make that mistake when I ask them, what is 1 divide 2? And they still think it's 2. See, if you follow what I've just showed you here, I'm dividing by 2. So when I write the operation, 2 should go on the outside. 1 goes in the inside. So what you're asking now is how many 2's fit into 1? That's why you get the 0 and it ends up being 0.5. That's where it comes from. Okay? Whereas over here, you're saying how many 4's fit in 232? So let's go. How many 4's fit in 2? Can I please have Lucas? 0. So it can't fit into it. So that 2, which is the hundreds column, now goes into the next column. So now we have 23 tens. Yeah, instead of 2 hundreds, I have now 23 tens. That's what they're doing. So they carry the 2 over and now have 23 tens. So you say the same thing again for the next line. How many 4's fit into 23 tens? Can I please have, is that your hand up? No? Okay. How many 4's into it? Sully? 5. Very good. 4 times 5 is 20. So what's the remainder? 23 and 20. What's the remainder? Yes, Kyle? 3. So I carry the 3. So the 3 tens move into the units column. That's why it becomes 32. 32 units. So then you say, how many 4's fit into 32? What is that, Wendy? How many 4's fit into 32? 8. Very good. And then it's 0 remainder. So you write 58. Okay, so this is short division. You can do long division if you've learnt that before, but these are the 2 mental arithmetic skills that you can do. Okay. Copy that down, and these are our last 2 examples. And then you can then have a go at exercise 1B. Okay, so long division, short division. These are the 2 skills from fluency. Then you do problem solving if you're up for it. Okay. Let's teach you how to do long multiplication, because not everyone knows how to do long multiplication. Long multiplication. Let's do it. So 412 times 13. First thing is make sure to write them in their columns. Units, tens, hundreds. You start off with the second row, and I'm going to start with the units. So 3 groups of 2. 3 groups of 2 is equal to what? Let's go with, who have I chosen? Josh. What's 3 times 2? 6. Very good. So we put down 6 in the units column. Then you do the same thing again. You take the 3 groups of 1, but remember that's not 1 unit, that's 110. So that's like saying 3 times 10. That's why it goes into, yes, that's 30. That's why when you say 3 times 1, it's 3, it goes into the second column. That's why it's 36, okay, because that's 110. Then you do the same thing. You then say, all right, well then I need 3 groups of the hundreds column. 3 times 4 gives you what? Can I please have? Who have I chosen over here? Colleen. 12. And that's 12 hundreds because it's in the hundreds column. And that's why it's 1,236. Okay? So you just done the 3. You finished the units. You've done the 3. That's one section. But you still have that 1. That 1 is in the tens column. So now we do the same thing. We say, all right, let's work with a tens column. We say 10 times 2, or technically it's 1 times 2. What's 1 group of 2? What's 1 times 2? Can I please have, let's go with Ashwin. 1 times 2. 2. Now this is where you got to be careful for those who aren't good with long multiplication. The 2 doesn't go in the first column. It goes into the second because you're starting in the tens column. That 1 times 2 is not 1 times 2, it's actually 10 times 2. That's why you have 20. That's why we write 20 there. Then you do the next one. Excuse me, team, don't speak while I'm speaking. Rule number 1. 1 times 1, 1 times 1, which is 1. Then you do your final step. 1 group of 1 was 1. 1 group of 4. 1 times the 4 is the last step. Now we add them all together. So in the first line, I had 1,236. When I went into the second place, I had 4,120. Adding them together gives me a total of 6, 5, 3, 5. This is called long multiplication. So some of us may struggle with this. This is in fluency. Practice it. So if you're good at 1-digit ones, good. Try 2 and try 3. You want to be sure that you can do long multiplication. It's part of your learning map. So you see long multiplication, you've got to be sure that you can do all versions. All right? Next one, short division. Same thing again. I'm going to draw my operation. Now, what number goes on the outside? Can I please have, even I chosen on this side? Have I chosen everyone here? Elizabeth? What number goes on the outside? 4, very good. So we're saying how many 4s fit into 951? Let's start off. We've got, yes, Elliot. Very good. So you start off, how many 4s fit in 9? You got 2. Remainder what? 1, because 2 times 4 is 8, and that's a 9, so we're missing 1. Carry that 1. Carry that 1 across. That now becomes 15. 15 tens. Okay? 15 tens. So now you say, how many 4s fit into 15? Very good. 3. Yes, you should have your hands up. Now 4 times 3 is 12, and this is 15, so what's the remainder? Bo. Is it? 12? No. So 12 and 15, what's the difference? 3. So you carry the 3 over to the next one. So that's now 31 units. And then you ask yourself again, how many 4s fit into 31? Ava? 7. Because 8 times 4 is 32. It's too big. So it has to be 7. Now 7 times 4 is 28. What's the remainder? Yes, Kyle? 3. Very good. So then you write R equals 3. So it fits in 237 holes with a remainder of 3. Now, out of curiosity, does anyone know how to write that as a fraction? Because that's 237 holes. What do you do with a 3? Anyone know? Yeah, it is right. 3 over something. What's the number? 4. Was that the answer? It is, but I didn't want to scare people yet. Some people don't know how to do long division, so I didn't want to convert that. But you need to know it can be, just for you to know, that's the remainder. That's your divisor, so it's always out of quarters. That's why it's 3 out of 4. That's your leftover. If you did decimals, it would be 0.75. Okay? But that's it for today. 2 skills, short division, long division. You must master that in fluency. If you're pretty good at that, try some problem-solving questions. Okay, but at bare minimum, all of you should be able to do fluency questions from 2 to 5 without a problem with these 2 algorithms. You must learn these 2 algorithms. Okay? I'm going to stop the video. If you want a challenge on the back of the sheet, there's a bit more for you to try. I'll write the solutions up soon. I'll leave those examples.